Alright, these are the last two examples from section 10.5. So we have 6 over x plus 3 equals 4 over x minus 3. This one's a little bit different, but you can use the same approach. We always want to start with restrictions. So x plus 3 cannot equal 0, and x minus 3 cannot equal 0. So x cannot equal negative 3, and x cannot equal positive 3. We just kind of keep that off to the side before we start working the problem. Let me see if that'll focus a little bit better. Alright, so because there's just one fraction on the left and one fraction on the right, if you want to, you can cross multiply, if you remember how to do that from a previous math course. If you're not comfortable with cross multiplication or you don't want to learn something new, you can do the same thing we've been doing. We're going to make common denominators. So this fraction needs x minus 3 over x minus 3. That fraction needs x plus 3 over x plus 3. Once the denominators match, we can ignore them. This does the same thing as cross multiplying. We can distribute the 6 and distribute the 4. And I'm going to go ahead and work it on here. That gives us 6x minus 18 equals 4x plus 12. From there, we'll solve for x. This is a nice, easy, linear solve. Move the 4x. It's going to give us 2x equals 30. So x equals 15. 15 is not one of our restrictions, so we're good to go. Example 8 is very involved. There might be one of these on your homework, maybe two. It's a very, very involved problem. First thing that makes it tricky is the subtraction. And then you've got complicated denominators that need to be factored. So I'm going to work this on a separate sheet of paper. You definitely want colored pencils for this one. It can be really tricky. So the first denominator factors into 2z minus 1 and z plus 2. Minus, I'm going to leave a big space here, 1 over 2z equals 3 over, and there's a GCF on that one, z times z plus 2. So I'm leaving a big space on purpose, you'll see here if you don't already. Before we keep going, let's do our restrictions. So you have to factor and take out GCFs before you can do your restrictions. So your restrictions, x cannot equal 1/2. I'm sorry, not x, z. Z cannot equal 1/2. Z cannot equal 0. Z cannot equal negative 2. So 3 restrictions we have to look out for when we get our solutions. So now that everybody's factored, I want to make sure that minus is nice and bold there. Colored pencils come in very handy for this one. We have 2z minus 1 on the first one, but the middle one does not have 2z minus 1. And the last one does not have 2z minus 1. So now they all have 2z minus 1. We've also got z plus 2 on the first one, and we've got z plus 2 on the last one, but the middle one does not have z plus 2. So now everybody has z plus 2. The last part to me is the trickiest. The middle term has 2 times z. The first term doesn't have either of those, so we'll have to do 2z over 2z. So now that one has 2z, that one has 2z. This one has a z, but it doesn't have the 2. So wherever you have room, we're going to have to multiply on a 2. That way it also has 2z. So color coding can help. Now they all have 2z, they all have 2z minus 1, and they all have z plus 2. And that can get a little tricky. Notice how much side-to-side space you have to really fit all that in. Now that all the denominators match, I'm going to go ahead and ignore those. I have a lot to clean up on top. We have 2z times z, which is 2z squared. I'm going to leave that minus alone for a minute and open a parentheses. I'm going to FOIL these guys. Multiplying by 1 won't change anything. So that's going to give me 2z squared minus z plus 4z minus 2 equals 2 times 3 is 6 times 2z minus 1, which I'll have to distribute. So like I said, lots going on this problem. We'll have to distribute that subtraction as well. Just keep cleaning it up. So 2z squared minus 2z squared, that's going to become plus z minus 4z plus 2 equals 12z minus 6. This 2z squared and minus 2z squared zero out, which is quite nice. That makes a linear equation. The plus z and the minus 4z make minus 3z plus 2 equals 12z minus 6. Now it's linear, so we can solve it. I'm going to add 3z. However you want to solve it is fine. I'm going to add 6. That's going to give me 8 equals 15z. Divide by 15. And z is 8 over 15. And so this was example 8. So always label your scratch paper. I'm bad about that. So always go back and label your scratch paper so you can use it and see it later. But that one's pretty messy. That's pretty rough. Comes down to a linear answer. It's not one of my 3 restrictions, and so my answer is valid. Z equals 8 over 15, and you can just leave it as a fraction.